For section 2.3, we are using deductive reasoning to verify conjectures. So deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. We use this to prove that a conjecture is true. So for example 1 here, urban legends and modern myths spread quickly through the media. Many websites and television shows are dedicated to confirming or disproving such myths. Is each conclusion a result of inductive or deductive reasoning? We learned about inductive reasoning back in section 2.1, and inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. And deductive reasoning is using logic to draw these conclusions. So part A here, there is a myth that toilets and sinks drain in opposite directions in the southern and northern hemispheres. However, if you were to observe sinks draining in the two hemispheres, you would see that this myth is false. So since this was actually observed, there were people that went and checked this out, I guess. This is inductive reasoning. The next one, part B, says that there is a myth that you should not touch a baby bird that has fallen from its nest because the mother bird will disown the baby if she detects human scent. However, biologists have shown that birds cannot detect human scent. Therefore, the myth cannot be true. This is deductive reasoning because they didn't do the test on whether or not the mother bird would take care of the baby after it had fallen. They just moved forward and said that they did their testing on whether or not birds can detect human scent. So they weren't actually testing the mother taking care of the baby. So this is deductive reasoning because we're using something else that had been proven. Then we're going to talk about the law of detachment. So if you have the if P then Q statement that is true, and P is true, then Q is true. So example 2, determine if each conjecture is valid by the law of detachment. So we are given that if two segments are congruent, then they have the same length. And I see that my congruent symbol did not transfer over into Cami. So it should look like that. So AB is congruent to XY, and the conjecture is that AB equals XY. The hypothesis of the statement is that two segments are congruent, and the conclusion of this statement is that they have the same length. So two segments are congruent as our hypothesis, and that is true because that's what it tells us here. AB is congruent to XY. So if the hypothesis is true, then the conjecture is, by the law of detachment, the conjecture is true. So then this is true, that AB equals XY. So the hypothesis is true. Oops. Say that this conjecture is valid. For part B, we are given that if you are tardy 3 times, you must go to detention. Shay is in detention. So our conjecture is that Shay was tardy at least 3 times. So our hypothesis, if you are tardy 3 times, then you must go to detention. So is our conclusion. And our hypothesis is if you're tardy 3 times, but we don't know that that is the reason that Shay is in detention. It just says she is in detention. So we can't prove that our hypothesis is true based on this statement. So therefore, Shay could be in detention for something other than tardies. So we are going to say that this is not valid. So these questions are just answers of, are they valid or are they not valid? And this one, we can't prove that Shay is in detention because of being tardy. So that would be not valid. Up above, two segments are congruent. We had the statement given to us that AB was congruent to XY. So we could prove that was true. So therefore, our conjecture has to be valid. And then lastly, we have the law of syllogism. And it says that if P then Q and if Q then R are true statements, then if P then R is a true statement. So basically, they both involve Q. And if they are both true statements, then we can take the beginning part of the first one and the conclusion, the hypothesis of the first one, the conclusion of the second one, and make a true statement. So for example 3, determine if each conjecture is valid. So we are given that if the measure of angle A is less than 90 degrees, then angle A is acute. If angle A is acute, then it is not a right angle. And then our conjecture is if the measure of angle A is less than 90 degrees, then it is not a right triangle. So looking back, if I can zoom out enough to have that up there, it says if P then Q, and then if Q then R. So let's identify those. The first statement, if the measure of angle A is less than 90, would be our P. Then our Q would be the then statement, angle A is acute. So with that being said, then we should turn around and go to if Q, then R. So our next statement, it says if angle A is acute, which was our Q statement, so that's good. Then R, then it is not a right angle. So then we should be able to take from that and create the if P then R statement. So we should say if the measure of angle A is less than 90, then the angle is not a right angle, and that's exactly what our conjecture says. So this is valid. For part B, it says given. So the first thing given, a number is divisible by 4. So that's our P. Number is divisible by 4. Our Q is the then statement. It is divisible by 2. Then our next statement should begin with this Q statement. If a number is even, but it doesn't. It starts with if a number is even. It should say if a number is divisible by 2. So we can stop right there and say that this is not valid. It does not follow the pattern that was given in the law definition. So we can just say it's not valid. We don't have to move any farther. Example 4, draw a conclusion from the given information. Given, if a team wins 10 games, then they play in the final. If a team plays in the finals, then they travel to Boston. The Ravens won 10 games. So we can conclude from that information that the Ravens are going to travel to Boston because they won their 10 games. And then part B, given if two angles form a linear pair, then they are adjacent. If two angles are adjacent, then they share a side. Angles 1 and 2 form a linear pair. If they form a linear pair, then they are adjacent. And if they are adjacent, then they share a side. So we can conclude from this that if they're a linear pair, they share a side. So angle 1 and angle 2 share a side.